Okay, so we had a very interesting conversation. You wanted to investigate arctan of a half plus arctan of a fourth plus arctan of an eighth plus arctan of 1 over n equals pi over 3. So what did we do there?
So we followed pretty much the same process as we did for our original problem. But instead of pi over 4, it was pi over 3. So that means the imaginary part had to be the real part times root 3 because of the pi over 3 degrees, or pi over 3 radians. And we found that this was our solution. It's not really any known number. It's not like a famous number or anything that we know.
Yeah, well, it's certainly not an integer.
Yeah.
It's a pretty interesting number. Negative 10 minus 11 root 3 over 11 minus 10 root 3.
Yeah.
So it is known. And it wasn't a famous number until when?
Until we discovered it as a solution.
Now it's one of the most famous numbers there is. So an interesting question about this number, minus 10 minus 11 root 3 over 11 minus 10 root 3, is actually, is it positive or negative?
Looks like it's actually positive because the top is clearly negative, and then the bottom is also going to be negative.
Okay, yeah, how do you know the bottom's negative?
Well, root 3 is like 1.7-ish.
Yeah, around 1.7.
10 times 1.7 is 17, so 11 minus 17 would be negative.
Yep, very good. All right, so you wanted to do something that was really cool, actually, which was the arctan of the Fibonacci numbers. So 1 plus 1 plus a half, the inverse of the Fibonacci numbers. It's third plus the dot. So we actually, how did we study this?
So we looked at what each of the products were. Like we did the product of just here, and then here, and then here, and then we kept going. And then we looked at the ratio between the real part and the imaginary part. I think it was
Well, the other way around.
It was imaginary over real.
Yeah, so we got the angle.
Or yeah, and then the angle we looked at the angle went over like this a little bit.
Yeah.
And then
so that 164 degrees.
Wasn't it negative 2 point?
That's right. Yeah, it was the we were getting. That's what this picture was showing. Actually, the arctan was negative, but arctan's range is minus pi over 2 to pi over 2. So we actually had to shift it over into here because we knew we were around 100. Was it 164? Am I remembering that?
Yeah, 164.9.
Okay. Yeah.
Something, and then we found that the ratios converged to this radian value.
Well, yeah. So the ratios converge to a tangent that would imply this value, some number of radians, 2.879299.14897.
Wasn't a special number or anything. It was just what this happened to converge to.
Yeah, it certainly. We didn't prove that it converged. It certainly looked like it was converging.
Yeah.
And of course, the Fibonacci numbers get big quickly. So I certainly am willing to believe this converges. But yeah, unfortunately, it would have been fun if this was a nice number, but we couldn't find any number that looked nice. It wasn't any nice rational multiple of pi or anything. But still, it was cool. That was a neat question to look at.
Yeah.
All right. Good work, guys.